Assalamualaikum warahmatullahi wabarakatuh. My name is Nabatia binti Idris. So for the introduction, the foundation is a key structural that transfer building loads to the ground, ensuring stability and safety. The second one is foundation are classified into two types, which is shallow foundation for shallow, deep, and deep foundation for tall structures. In this project, group design foundation for petrol stations at assigned locations. So the foundation type was selected based on bearing capacity, settlement and soil improvement needs to ensure safety and stability.
Assalamualaikum, my name is Nur Afrina. I want to talk about the project background. Our company name is Salford Sdn Bhd, and then company address at Kuala Berang, Hulu Terengganu, and then company form of the business is construction. Date of business registration is 27 February 2021, and then initial capital for this company is RM 1 million. Okay, next about the vision and mission. So about the vision for our company is, our vision is to become the benchmark of civil contractor and construction for industry such as building, roads, food and beverage and real estate. And next for the mission is, our mission is to establish a professional organization capable of providing outstanding service based on compromising quality to our value client. So the first is product high quality work according to specific engineering standard. Second, delivery quality product that exceed the expectation of client. And the last one is timely delivery of project with compliance with safety requirement. Okay, next I will explain about the organization chart. For our company, we have Fiza Idea as a director, and then Sharifah Nazira, project manager, Sofiatul Adira as a civil engineer, Nur Hafiza as a quantity surveyor. And then we have two site engineer for our company. The first one is Nur Fatiha, and then Nur Afrina. Okay, that's all from me. Thank you.
Assalamualaikum, my name is Sofiatul Atira binti Abdul Razak and my matrix number is CF220169. I will explain about the proposal of foundation engineering design. So, shallow foundation. Shallow foundation is a foundation that bears at a limited depth below the ground surface, such its depth is less than approximately twice its width, which is D is less than 2 times B. So there are many kinds of shallow foundations, which is spread footing, continuous footing, rough footing. And for this project, we use spread footing. Okay, next, a spread footing distributes the load from a column to prevent shear failure and reduce settlement by applying less bearing stress. Its size depends on the column load and the strength and deformation capacity of the soil beneath it. Next, the ultimate bearing capacity of a soil therefore means the loading per unit area, which will just lead to shear failure in the soil. It is given the symbol QULT, and the allowable bearing capacity can be defined as the load per unit area of the soil which can safely be applied out unstable movement. The symbol is QAll, and it also known as design bearing capacity, and the formula is QAll equals to QULT over Fs. So here is the table for properties unit, which for each layer of soil, which is layer 1, 2, 3, 4 and 5. So for the depth, layer 1 is 0.0 to 0.3, layer 2 is 0.3 to 0.6, layer 3 0.6 to 0.9, layer 4 0.9 to 1.2, and the last one, layer 5, is 1.2 to 1.5. Okay, for the SPT value, which is the unit is blows, there is increase in depth, which is from soft to hard soil. For the layer 1, 30, layer 2, 83, layer 3, 86, layer 4 is 139, and the layer 5 is 400. Next, for the unit weight, layer 1 is 18.5, layer 2 also 18.5, layer 3, 15.7, layer 4, 15.7, and layer 5 also 15.7. For the friction angle, Each layer is same, which is 7, and the cohesion each layer also is the same, which is 30. Okay, for the last one is the summary of design. For column 1, the proposed size is 0.7 times 0.7. The Q all is 291.41 and the settlement is 2.52. For column 2, the proposed size is 0.9 times 0.9. The Q all is 291.52 and the settlement is 2.69. C3, the proposed size is 1.0 times 1.0. Q all is 291.56 kN and the settlement is 2.84 millimeter. For column 4, also the proposed size is 1 times 1. The Q all is 291.60 kilonewton and the settlement is 2.84 millimeter. And the last one is C5, which is column 5. Also the proposed size is 1 times 1. The Q all is 291.65 kilonewton and the settlement is 2.84 millimeter. And all the column settlement check is less than 25.
Project structure description of project. This section discusses the soil investigation work for proposed petrol station at Gateway Puchong. The aim of this investigation is to achieve geotechnical engineering information that underlies the site in order to provide data in the design and evaluation of the proposed structural foundation. In total are 3 nodes, borehole and 6 nodes. Macintosh probe tests that were conducted at the site. The deep borehole were advanced and rotary boring Shane WE D90R. Load used at every column. The columns were divided into 3 groups of load as shown in Table 3.1, whereas Table 3.2 summarizes the load applied on all columns. The load of the column in project was divided into group range which is from 0 to 400 kilonewtons. Therefore, there will be 3 groups that with the range of 100 and 200 kilonewtons. The maximum load is from C5 which is 302.36 kilonewtons and the minimum load C1 is 140.4 kilonewtons. C1 is 140.4, C2 is 215.3, C3 is 242.0, C4 is 273.9 and C5 is 322.3. For table 3.2, grouping of loads is Group A, 0 to 100 column load, categories is unknown. B, Group B, 101 to 200, categories is column 1. C and 201 to 400, C2, C3 and C4, C5. Borelog definition: record of in situ condition and characterize the organical exploration. Purpose: provide detailed information on soil and rock properties, aiding in evaluation and decision making. Data collection method: visual inspection, sample from geotechnical process, geophysical measurement along the drill axis using specialized log equipment, recording data long in a regular spreadsheet. Importance of bore log data: soil consistency and types help in understanding soil behavior. Water table: information on groundwater level, formation evaluation, determine suitable of formation for specific uses. Water quality assessment: identify if borehole water needs treatment. Testing method used: natural moisture content, Atterberg limits, particle size distribution, unconsolidated undrained fragile compression test, one-dimensional consolidation test, Macintosh probe test. Type of soil: gravel. Borehole depth meters 32.10. Water table is 12.99. It's a table result for BH2. For soil profile is a vertical segment of the soil that shows all of its layers. The soil profile extends from the soil surface to the parent rock material. It allows you to examine the structure and characteristics of soil, which obtain the laboratory test. The result of soil characterized from SI to site investigation report will be shown in tab 3.4, whereas this is a table 3.4, the result of soil characteristics for Atterberg limit test. This is the result of soil characterized for particle size distribution test. This is a summary of soil profile from table 3.6 that you see the depth of the ground level is 0.0 until 20.0. So this is a property of soil for N13 to N11. This is a summary of soil profile from 21 to 30.3.10. So this is from 21 to 30.3. The soil profile and the layer of the soil. This is the one of the sample that we investigate. This is one of the soil profile from the layering, medium stuff very stiff and hard.
Hi, Assalamualaikum. My name is Nora Fizza binti Basri and my matrix number is CF220185. So today I will explain about analysis of foundation. So we use the Zaghi method. The load for the first foundation is 140.4 kilonewton, and then we calculate Q and we calculate the QU, which is 872.85 and 1.995 B, and then we calculate QR and we apply pressure to the ground, which is 140.4 over B squared. Then we get the two equation and we use the by try and error method, and we can get the value of B, which is 0.964 meter. Then we go to the checking. Then we checking the value of QU is 874.24 kilonewton, and the QR is 291.41 kilonewton, which is greater than 140.4 kilonewton. So the second analysis is we also use the Zaghi method, and the load is 215.3 kilonewton. The flow of calculation we still same, and we calculate Q, QU and QR. So we apply pressure to the ground, which is 215.3 divided by B2, and we get the value of B, and by using by trial and error, which is we can get 0.86 meter. And the checking is the value of QU is 874.57 kilonewton, and the QR is 291.52 kilonewton, which is greater than our load, which is 215.3 kilonewton. So the next one is we also use the Zaghi method, and the load is 342 kilonewton, and we calculate the value of Q, QU and QR. Then we apply pressure to the ground, which is 342 over B squared, and we can get the value of B by using trial and error method, and the value of B, which is 0.911 meter. And we go to the checking. We got the QU 874.967 kilonewton, and QR, which is 291.57 kilonewton, which is greater than our load, which is 242 kilonewton. So the next load is 272.9 kilonewton, and we calculate still using the same method, which is the Zaghi method. We calculate the value of Q, QU, QR, and we can apply pressure to the ground, which is 272.9 over B squared. And we got the value of B by using trial and error method, 0.967, and we go to the checking. We got the QU 874.78, and QR is 291.59, which is greater than 272.9 kilonewton. So the next load is 322.3 kilonewton. We calculate the value of Q, QU, QR, and apply pressure to the ground, which is equal to 322.3 over B squared. And then we got the value of B 1.05 meter, and the value of checking is 874.95 kilonewton, and QR 291.65 kilonewton, which is less than 322.3 kilonewton. So the next one is for settlement checking. For the column 1, we propose the size which is 0.964 times 0.964. Then we determine the net allowable bearing pressure, kilonewton per meter square, which is we get the net allowable bearing pressure 2428.88 kilonewton per meter square. Then we determine the settlement which is B mass less than 1.22, and then we got the settlement 2.52, which is lower than 25 millimeter. So we can accept this column 1 value. For the column 2, we propose size 0.86 times 0.86, and then we determine the net allowable bearing pressure, and we got 2154.12, and then the settlement we got 2.69, which is lower than 25 millimeters, so we can accept this value. So the proposed size for the column 3 is 1 meter times 1 meter. The first one is we got the net allowable bearing pressure, which is 2000.96 kilonewton per meter square, and then the value of the settlement is 2.85, which is lower than 25 millimeters, so we can accept this value. And then for column 4, the proposed size is 1 meter times 1 meter, and then we get the net allowable bearing pressure is 2096 kilonewton meter per square, and the value of the settlement is 2.84, which is lower than 25 millimeter, and we can accept this value. Next is the proposed size for column 5, which is we propose 1 meter times 1 meter, and then we got the net allowable bearing pressure 2000.96 kilonewton per meter square, and then the value of the settlement is 2.85, lower than 25 millimeter, so we can accept this value.
My name is Sharifah Zira binti Said Kamil Rifai, and my matrix number is CF220137. So here I am to explain about the discussion and conclusion. Discussion. A 5-person team managed the petrol station project at Gateway Puchong. They analyzed soil data and determined the required to support the station. Columns were grouped based on the load capacity, with size range from 0.7 meter length, 0.7 meter width to 1 meter length and 1 meter width. A shallow spread footing foundation was recommended, and settlement check confirmed the foundation stability. To manage groundwater, a deep well drainage system will be installed to ensure the soil will remain stable for the piling foundation. Conclusion. Through the research, our team learned how to design a foundation using the shallow foundation approach. We conclude that a spread footing foundation is suitable for this project, as it can adequately support the structure. Even though a pile foundation could be used within the budget, generally low-rise building 1 to 4 story benefit from distributed foundation requiring firm soil to support the structure. This approach is both physically and financially safe, making it its preferred choice. References. We refer to two websites. One is a borehole log environmental standard retrieved January 28 year of 2023, and soil profile soil management January 28, 2023. Thank you for your time and attention. Assalamualaikum.